Visible light can be represented by sinusoidal waves. 3 visible light waves are shown in the graph below. The midline of each wave is labeled L. So it looks like all 3 waves have the same midline. Based on the graph, which light wave has the longest period? Justify your answer. So how we define what a wavelength is looking at the distance from peak to peak. So how do we do that? Or actually, it doesn't have to be from peak to peak. It just has to be from one point on the curve to the same exact point on the next cycle. So looking at this, I'm going to use different colors here. So let's say curve A, okay? I notice that the peak happens here, and then the next peak will happen like right about right there, okay? So what is that? For peak A, I'm going from 80 to 600, okay? So 80 to 600, or 600 minus 80 is for A, and that would be 520. That would be the wavelength for wave A. Let's do wave B. Okay, so wave B, I need to go from peak to peak, right? Or from one point on the curve to the same exact point on the next cycle. So I want to say the point on the curve is like right here to there. That's one full cycle right there, okay? Because if I go again, this is one full cycle, all right? So looking at this, I'm going to say roughly at, let's say in red. So over here, I'm roughly at, I'm going to say 55, right? That's the end, or that's the start rather. And then the next one will be so we're going 480 to 520. So 510, I would say that would be roughly 510. Okay? So 510. Actually, I made a mistake. The starting is not 55. The starting would be, let's see, 60, 70, I would say. My bad. Right? So that would be 70. And let me double check that. This point over here, is it going to be, let's see, 480, 500, yeah, it will be around 510. I want to say 510. So 510 minus 70, what is that approximately? That would be 440 then. So that would be 440. So right now, wave A is the longer one, but let's check out wave C. So wave C, wave C, well, wave C happens over here, and I'm going to erase this. Wave C, I can see that this is going to be half a wave, right? The other half would come over here, like so. But we don't have like an actual number here. There's no actual number for us to calculate that with. So what we're going to do is we're going to do a little bit of we're going to be a little clever here. So that number there, that's 50, right? Or not 50, that is 60. This number over here, what is that? That is precisely 380. Now, if I take 380 and minus 60, right, I will get half of a wavelength. So to get the full wavelength, I'm going to need to double this by 2. So the full wavelength, what is that? 380 minus 60, that's 320. And if I double that, I'm going to get 640. So looking at this, okay, it says based on a graph, which light wave has the longest period? Justify your answer. So I want to say wave C has the longest wavelength. Measuring at 640 nanometers. And followed by, I want to, B, followed by A with 520 nanometers, followed by B with 440 nanometers. That's it.